Hello everyone, welcome back to the channel. Let's start the characteristic fragmentations of organic compounds. Right? From this video onwards, we are going to have the brief discussion on the fragmentation procedures of different kinds of the organic functional groups. Let's start with the first type of organic compound, that is commonly called as what? Alkane. Okay, in case of the alkenes, what is the first point? We are going to observe successive loss of CH2 units. It means that what? Alkenes are the what? Straight chain or branched chain organic compounds, right? By the elimination of the single electron, we are forming a molecular ion. That molecular ion is subjected to the fragmentation procedure or not? So during that fragmentation procedure, what should we do? We need to remove one CH2 unit every time. Carbon weight 12, it means carbon mass number 12 and 2 hydrogens 2. It means that what? 14 mass number we need to remove. Okay, that is the first point. The second one is what? In case of the branched chain alkanes, loss of long carbon chain radical is preferred. It means that what? If you take any kind of the branched chain alkane, we are having the branch and remaining straight chain part. The straight chain part always be removed in the form of a radical. The branch should be having the positive charge. Why? Because comparing with the carbons which are present in the carbon chain in a straight chain, the branched chain carbocations are highly stable. That's why always the branch should be get positive charge, remaining straight chain carbon chain should be get a radical character. Okay, next one. C3, C4 fragment peaks are more intense peaks. It means that what? Whenever you are cleaving the C3 bond or C4 bond, you will get the corresponding fragment ions or not. Those ions intensity is higher. It means those peaks will appear with the more height in the mass spectrum. Okay, let's see one example. Here it is an alkane. Here it is an alkane or not? 1, 2, 3, 4, 5. 5 carbons are present means it is a pentane. Right? In case of these straight chain organic compounds, where should we form the molecular ion? At the terminal carbon-carbon bond or not? So by using the electron impact, what is happening? We have removed one electron from this particular bond. Thereby we are getting what? Plus radical. I can write the plus radical in this way also. Radical plus. Suppose if I subject this one to hemi-heterolysis, what will happen? CH2 plus CH3 radical. But if we take this one and subject this one to the hemi-heterolysis, what will happen? CH2 radical and CH3 plus. Right? So comparing with the long chain carbon cation, the methyl cation is less stable. That's why always we are using this kind of situation. Always you need to put it in your mind that the produced ion should be more stable carbocation. In such a way we need to write the molecular ion. Now it is subjected to what? Hemi-heterolysis. Thereby what happens? CH3 radical will be removed and CH2 plus will come. See this one? CH3, CH2, CH2, CH2 plus. Okay. Now what we need to do? Every time we need to remove the CH2 unit. See this one? Do the heterolytic cleavage. What is happening? Already positive charge is there. We are giving the negative charge. The positive and negative can be neutralized or not. Thereby the CH2 carbene will be removed. So CH3, CH2, CH2 plus. Again CH2, CH3, CH2. Again CH2. You will come up with methyl cation. So it means that what? 1, 2, 3, 4. If you remove this one also, you will get methyl cation. So finally we are getting 5 peaks for this particular compound. Okay. Suppose if you have the branched chain. In case of the branched chain, what should we do? We need to have the molecular ion formation at the branch. See this one? At this particular bond we are preparing what? Radical cation. I can write plus radical also. If I write plus radical, CH2 will take positive charge, CH3, CH2, it is the primary carbocation or not? Now it is what? Secondary carbocation or not? Comparing with the primary, secondary carbocations are more stable. That's why we are writing in this way. Radical plus. Do the hemi-heterolysis. What is happening? CH3, CH2 radical will be removed and we are getting the branch. The branch is going to have positive charge. See the second one. In case of branched chain, loss of long carbon chain, radical is preferred. See, CH3, CH2 radical is preferred. Why? Because the produced carbocation is more stable in this case. Okay. Next. See the situation. If you have the ethyl group, from the ethyl group we can remove H2 by doing the homolytic cleavage. Thereby you will come up with one type of cation. It can give a peak. From this particular ethyl group, simply if you remove the hydrogen radical, what will happen? You will come up with the radical or not. So this plus and radical can form a radical cation. So in this way, we are going to have different kinds of the peaks for the alkanes. So whenever you are getting the any kind of question in the net examination, you need to follow these rules, these three rules. Based on these three rules, you can easily do the fragmentation process. So this is about what your alkanes. Now come to the next one, cycloalkanes. In case of cycloalkanes, what should we do? Loss of ethene takes place. Already we know that in case of the cycloalkane, the formation of the molecular ion takes place by cleavage of any carbon-carbon bond. See the molecule. What should we do? We need to form a molecular ion. For that purpose, what I am doing, I am removing one electron from this particular bond. Thereby we are getting what? Molecular ion or not? So here what is happening? These two bonds are subjected to homolytic cleavage. Thereby what will happen? You will get the radicals here or not? So these two radicals can form a pi bond. So ethene is removed. Ethene is removed, then this is subjected to cyclization. You will get this kind of ion in the spectrum. Suppose if you are having a substituted cycloalkane. See this one. In case of the substituted cycloalkane, what the people are saying? Loss of alkyl radical is preferred. That's why here we need to form the particular molecular ion. See this one, plus radical. Do the hemi-heterolysis. Here we are doing hemi-heterolysis. Thereby what is happening? CH3 radical removed and cyclic compound is going to get a positive charge. Already we know that comparing with the aliphatic or simple cations, cyclic cations are more stable. That's why we are writing plus radical in this way. Okay. So this is about what? Cycloalkanes. In case of cycloalkanes, loss of ethene is one particular rule and loss of alkyl radical in case of the substituted cycloalkanes. These are the two rules in case of cycloalkanes. Now come to the next topic, that is alkenes. In alkenes, what is the first rule? Do the beta homolysis. Beta homolytic cleavage is the preferred one always for the alkenes. The second rule is what? In case of the olefin containing the gamma CH function, what should we do? We need to perform the McLafferty fragmentation. Already we had a brief discussion on the McLafferty in the previous videos. Right? Let us take one example. 1, 2, 3, 4, 5. 5 carbon. Right? It is one pentene or not? So if you do the fragmentation procedure for this particular moiety, so what kind of peaks we can get? Let's see. It is a pi bond containing molecule. That's why molecular ion is formed at the pi bond or not. By doing the electron impact, what is happening? Okay. Molecular ion is formed or not. Now what should we do? What is the first rule? Beta homolysis. Beta bond is subjected to the homolytic cleavage. See this one, with respect to this pi bond, this is alpha bond, this one is beta bond. So do the beta homolysis. What will happen? CH3, CH2 radical and CH2 radical. This CH2 radical and this CH radical can form a pi bond. Thereby we are getting CH2 double bond CH, CH2 plus and CH3, CH2 radical is removed. Here I have used the term called as base peak. Base peak means the more intense peak in the mass spectra is commonly called as a base peak. Highest intensity line in the mass spectra. Suppose if you have 4 lines. See this line, it is highest intensity or not. That's why this peak is commonly called as base peak. Sometimes the molecular ion peak may be base peak or fragment ion may be base peak. See this one, this is a fragment ion or not. From the molecular ion we are getting this peak. Why it is base peak? Because it is a allylic cation or not, involving in the conjugation or not, right? Delocalized electrons or takes place in particular cation or not. Already we know that the carbocations which are involved in the delocalization, those carbocations are highly stable. So highly stable means highest intensity. So highly stable carbocations are going to be appeared in the mass spectra with the highest intensity. Okay, right. Suppose if I write this particular moiety in this way. In the previous case what happened? I have done the homolytic cleavage at this beta. See this one, with respect to this particular bond, the CH bond is also beta bond or not. So if I do the homolysis here H radical will be removed. So here we are getting a radical, this radical and this radical can form a pi bond. So CH3, CH2, CH double bond CH, CH2 plus. Right? In this particular moiety, see this one, with respect to this pi bond, this is alpha, this is beta and this is gamma. At gamma position we are having what? Hydrogen or not. So this is going to be involved in the McLafferty rearrangement. So whenever you are having any kind of alkene, you need to do 2 beta homolysis, one with the hydrogen cleavage, another with the alkyl group cleavage. 2 homolysis, and if the molecule is having any gamma CH function, do the McLafferty rearrangement. It means you are going to get 3 different peaks or not. The first peak, second peak and third. Okay. Now come to the cycloalkenes. It is something important comparing with the remaining things. We all are familiar to the Diels-Alder reaction. What is the Diels-Alder reaction? In Diels-Alder reaction, what is happening? The conjugated compound is going to be interact with the simple olefin. It can produce a cyclic adduct, diene and dienophile. Combination of diene and dienophile produces a cyclic adduct, cyclohexene. This is commonly called as what? Diels-Alder reaction. It is very well known reaction, right? In case of cycloalkenes, what we are observing, the reverse of the Diels-Alder reaction. See this one, these 2 olefins are combining to produce a cyclic olefin or not. If the cyclic olefin is subjected to the decomposition, what should we get? We will get simple alkene and conjugated alkene or not. The reverse process is commonly called as what? Retiro-Diels-Alder reaction. What is the name? Retiro-Diels-Alder reaction. So what is the fragmentation involved here? Retiro-Diels-Alder fragmentation is involved in case of cycloalkanes. So what will happen? See this example. Cyclohexene we have taken, subjected to electron impact. It is a pi bond containing molecule. That's why molecular ion is formed here. So here what happens? Homolysis of 2 carbon CC bonds takes place. Thereby what happens? Radical, 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 radical. So these 2 radicals can form a pi bond or not. So CH2, CH2 will be removed. Thereby we are getting what? 1, 2, 3, 4, 4 carbons. So these 2 can form a pi bond. These 2 can form a pi bond. So this is going to be observed in the mass spectrum. Okay, radical cations are always appeared. Neutral molecules will not be appeared. Okay, in case of this particular compound, so what is the difference? It is a simple ring. We have added one more ring. So there we are getting this product. Okay, simply ethylene is removed. What is the difference between these 2? Here it is a carbon, here it is a oxygen. Here we are having lone pair of electrons, right? That's why molecular ion formation takes place at this oxygen only. Then remove the C2H2, you will come up with this ion. This ion will be appeared in the mass spectrum. So in this way, we need to do the fragmentation of alkanes, cycloalkanes, alkenes and cycloalkanes. It's very simple or not? Fragmentation is always simple, just follow these guidelines. In case of alkanes 3, in case of cycloalkanes 2, in case of alkenes 2, in case of cycloalkenes only 1. You need to remember all the guidelines, then only you can do the fragmentation. Okay, so we will continue the fragmentation procedures of different functional groups in the coming video.